In this video, I will discuss a JEE Advanced PYQ from the topic Current Electricity. This question has appeared in the year 2022. Timestamps are given in the description box. You can watch parts of video if you are running short of time. This is the question. You can read it. The figure shows a circuit having 8 resistances of 1 ohm each, labeled R1 to R8, and 2 ideal batteries with voltages E1 equal to 12 volts and E2 equal to 6 volts. Which of the following statements are correct? Statement A, the amount of current flowing through R1 is 7.2 amps. B, amount of current flowing through R2 is 1.2 amps. C, amount of current through R3 4.8. Statement D, amount of current flowing through R5 is 2.4 amps. We should find the currents in the different branches. All the resistors are equal and it is 1 ohm. This cell here will drive a current like this, and this cell here will drive a current like this. The current which reaches this node will go like this and go like this, and it will split equally because about this horizontal line, the one above and one below are exactly same. So this is a symmetry line. So if this current is I1, then the same I1 will flow here. It cannot be different because of symmetry. And whatever current is flowing here, the same current will flow here. And this current will come from these two branches. And these two incoming currents will also be same because it's symmetric about this horizontal line. So if this current is I2, the current that's coming from bottom will also be I2 by symmetry. So this current is I1. This is the same current I2. So this current will be I1 minus I2. Applying KCL at this node. This current is I1. This current is I2. So this current is I1 minus I2. This current is 2I1 because these two should add to give this one. So this total incoming current is 2I2. So this current is 2I2. The current which is flowing in this direction is 2I1. This current and this current, it's I1 minus I2. So the incoming currents are twice I1 minus I2 plus 2I2. So I2 will cancel and the outgoing current is 2I1. So KCL is satisfied at this node also. So there are two unknowns, I1 and I2. So if I apply KVL in two loops, I can solve the question. So this is loop 1 and let me take this as loop 2. So KVL in loop 1, I write summation of voltage drops equal to 0. Along the direction of current in a resistor, there is a voltage drop. So the drop from here to here is I1 into the resistance value, which is 1. All the resistance are 1 ohms. And the drop from here to here is I1 minus I2 into 1. The drop from here to here is 2I1. And from here to here, there is a voltage rise. So the drop is minus E2. This is equal to 0. So this is KVL in this closed path, written in the form summation of voltage drops is 0. Similarly, in the second loop, so this we can simplify a little bit. So have 2I1. So it will be 4I1 and then minus I2 equal to E2, which is 6 volts. So this is one equation. And the second loop, applying KVL, drop from here to here is I2 into resistance is 1 ohm, plus the drop from here to here is 2I2, and there is a voltage rise of E1, so minus E1, and again there is a rise of I1 minus I2 because I am going the direction opposite to the current. So minus I1 minus I2 equal to 0. In a resistance along the direction of current, there is a voltage drop. So here I am moving along the direction of current, here also along the direction of current, here against the direction of current. The current is flowing downwards, I am going this way because that is the loop direction. So there is a voltage rise from here to here of value I1 minus I2 into 1 ohm. So this also I can simplify. I'll get 4I2 minus I1 equal to E1, which is 12 volts. I can forget the SI units. So there are two equations. Solve for the currents. So if I multiply this 4 times and add this, I2 will go away. So 4 times I1 plus the second equation will give me 4 times is 16, minus 1 is 15, I1 equal to 4 times this is 24 plus 12, which is 36. So this will give I1 as, cancel 12, cancel 3, and to find I2 I can use the equation 1. I2 equal to 4I1, 4 times I1 minus 6. So if we take 6 outside, this will become 8 by 5 minus 1. So it will become 3 by 5. Simple calculation. Take 6 outside, this will become 1. So this will become 8. So 8 by 5 minus 1, which is 3 by 5, which is 18 by 5. Amperes. So now we can check the statements. Statement A, current in R1. R1 is this one, that is 2I2. So this current in R1 is 2I2, that is 36 by 5. Which is same as 72 by 10, 7.2 amps. Option A is true. Option B, current in R2. Current in R2. R2 is it's I1 minus I2. So I1 is 12 by 5. So it's 6 by 5 minus 6 by 5. But what is equal to just the magnitude? So this same as 12 by 10. So 1.2. But the question is just the magnitude of the current. Magnitude of the current is 1. So B is also true. Statement B is true. And for statement C, current in R3. R3 is this one, that is twice I1, which is 24 by 10, 24 by 5, so it's 4.8. 2I1 is 24 by 5, which is same as 48 by 10, so it's 4.8. So option C is also true. And for option D, current in R5, R5 is here, which is I1, which is 12 by 5, it's 24 by 10, 2.4. So D is also true. So all A, B, C and D are correct statements. That is the correct answer. This is what I done here. So this circuit has got a symmetry about this horizontal line. All the resistors are equal. So if current I1 flows here, the same I1 will flow here. So that means this current will be 2I1. Similarly, this I2 is entering here, I2 will enter here also. So this current is 2I2. And this current can be got as I1 minus I2 by KCL at this node. So once you appreciate the symmetry of this problem, then it's very easy. So applying KVL in this loop, I1 into 1 plus I1 minus I2 into 1, all the resistors are 1 ohm. And the drop from here to here is 2I1 into R3, so 2I1. And there is a voltage rise minus E2. So this we can simplify as 4I1 minus I2 equals 6. E2 is 6 volts. In the second loop, it's just 1 and 2 are interchanged. Instead of 2, I have 1. So if you interchange 1 and 2 here, but for E2 I have to make it E1 and the value is 12. So I'll get 4I2 minus I1 equal to 12. So 2 equations, 2 unknowns. So to eliminate I2, I multiply this by 4 and add them up. I'll get I1 as 36 by 15, which is 12 by 5, which is 2.4 because it's 24 by 10. And I2, I use the equation 1 to get I2 as 4I1 minus 6. So that is 3.6 amps. So the options can be checked individually. Option A, finding the current in R1. So R1 is twice I2. That is 7.2. On option B, R2 current. R2 is I1 minus I2. I1 minus I2 is minus 6 by 5, it's minus 1.2, but they're just asking the magnitude. Option C, current in R3. R3 is 2I1, which is I1 is 2.4, so 2I1 is 4.8. Option D, current in R5. R5, the current is I1. And I1 is 2.4, so it's 2.4. So all the 4 statements are true.